or other sources, there is a real day-to-day loop. There's a lot of data coming in. So we have to move beyond the science of GIS. We have to get to a point where we're extracting true business value from all of this location-based data that we're collecting to something that represents business opportunity and business results. That is the key. So from GIS to location intelligence and from science to big data, that's what I'm going to talk about today. If you're not familiar with Pitney Bowes, we are a Fortune 500 company. We're about $3 billion in revenue a year. And we are very much focused not only on GIS, but e-commerce, mailing, and shipping. And most of you know us because we are the ones who produce MapInfo Pro, and we thank you for your business. So, what I perceive, and I have been in GIS for almost 40 years, and what I perceive is happening today is most of the work that's being done is data collection. We have to move beyond data collection. And that's what GIS has tended to be, is a data collection tool, where only 30% of the time is that we're doing spatial analytics and location analytics. Well, in my way of thinking, many of your work today is almost done. I mean, there still will always be data collection. And what Kumar was talking about was more of an automated feature extraction. So when we get to that point, and it is coming very soon, where we can have automatic feature extraction and change detection, we will need to start doing more location analytics. That is what we need to do. So we're going to have to flip this model between doing 70% of data collection to now doing 70% of our time dedicated to location analytics and finding the answers to key spatial questions. So Kumar's statement about doing a SQL query on satellite imagery is very much music to my ears, because I think that is where we need to get to. We need to teach people how to do simple spatial queries. Now let's think about this for a second. If you're not a geospatial scientist, if you're in banking or insurance or real estate, those people do spatial queries every day. They just don't realize they do spatial queries every day. Like if you're a real estate vice president, you will probably say to your real estate agents, show me all of the office space within 3 miles of Main Street on Sunday at 3 p.m. in the afternoon. That is a spatial query. But to translate that spatial query into something we can use in a GIS, well, that's something a little bit different. And we have to teach people how to do that. So mapping and spatial analytics really gives us, as you all well know, those proximity relationships that really reveal all of the business intelligence that comes from spatial data. So those results lead us to really new findings, and that's what I define as location intelligence. So where we need to get to is to, as I said to you with the example of the real estate vice president, is to think spatially. We have to teach people how to think spatially, to ask those spatial semantic queries so that we get to the answers faster. Because location intelligence answers the where questions, right? We have lots of where questions, and today, that is what business intelligence solution providers are trying to do as well. So there's this gray area between BI tools like Tableau and MicroStrategy who are providing some basic mapping and GIS. So there's this gray overlap. Now, what's GIS and what's business intelligence? But nonetheless, we are going to have to be the educators and communicate the value of location. However, we as geospatial scientists have a problem. We sometimes are, we sometimes fall into a trap that we call the cool map, okay? We love maps. This is a cool map, right? We have colors, we have graduated symbols, we have location. And that little legend at the top is showing the amount of megawatts generated by power plants in the United States. This is what we as geoscientists love, because it is just the greatest map. And when we show this to somebody, we expect them to be as enamored with the map as possible. But sometimes they're not that way. They just say, it's just a map, right? Tell me the real business value of that map. Tell me what I really need to know about that cool map. So, maps and imagery are not always the answer. And that is blasphemous to some of us in the room because we love maps, right? So let me take you down a path where you're going to need to tell the people who you're trying to sell GIS to, or you're trying to communicate to the mayor or the government agency, that we have real value. But sometimes these CIOs and VPs and presidents and mayors, all they want to know is, what's the answer? Tell me where to drill, okay? I don't need to see the map. Tell me where to locate my next store. That's the value of our location technology today. That's where we need to get to. And so there may be a special type of spatial challenge that we face, and we may need different tools to solve those challenges so we can get to the answers faster. So there's a realization, right, that clients want the answer, and that really means integrating business data with location intelligence. And organizations are using different tools, as I said, to get there better and faster. So, we must first recognize, as we've said throughout this conference, this explosion of geospatial information, right? It's coming from the Internet of Things. We all know that everything is going to have a location tag. Traffic sensors, pollution sensors, energy sensors, they're all generating all this data, all of which has a location component. Then we have mobile data from your phones, and I'm going to tell you in just a little bit about a use case that we did with a telecommunications company about how we extracted their data from mobile devices. And then, of course, as you all realize, there's social media. Everything, if you're using Facebook or another social media interface, you are generating location-based data. Twitter is actually a data company, if you didn't realize it. They are selling the data that every time somebody tweets, they're capturing location, they're capturing sentiment. Okay, you know what sentiment is? It's like, well, how good is my Starbucks? I'll give you a great example. You can tweet out there that says, I've never had a bad coffee at Starbucks. And in that sentence, there are 3 negative words. Bad, never. You would expect that sentiment to be a negative sentiment against Starbucks. Well, in actuality, what the person said was a very positive statement. So we have to take into consideration all of the sentiment information tied to a location. And we've actually done studies of sentiment relative to a location to tell Starbucks how good your store is performing. So it's a very qualitative measure, but it's very relevant nonetheless. So we're generating all this data, and we're requiring high accuracy in location. Here's an example about what retailers are doing in terms of deploying beacons inside of stores so that they're monitoring your whereabouts inside of a retail establishment. They're tracking you. They're seeing how long you spend at a particular department. That's called dwell time. So how long are you in the department? Where did you go? How long did it take you? And what did you buy? Again, all generating this location-based information. So this high volume of transactions is creating something, I'm sure you've heard this term, it's called big data. So I'm going to go into a little bit about how I define big data and really tell you how it can manifest itself in true business value. So you may have heard of something called the 7 V's of big data. Volume, velocity, veracity. I'm going to explain a little bit about what each is very, very quickly. We all know volume. We're generating voluminous data day in and day out. It's not just gigabytes, it's yottabytes. It's beyond petabytes, it's zettabytes. Okay, that's volume. Then we have velocity, the speed at which data is being captured. Again, Kumar just mentioned that we're going to have repeat visits every single day or maybe multiple times a day. That data is coming at us really, really quickly. Traffic sensors creating tremendous volume out of just a single sensor on a single pavement at a single intersection. UPS, the delivery company, they monitor everything that a driver does, not just where he drives and the speed at which he drives. They measure every time he unclicks the seatbelt, every time he opens the door. That's a sensor that's location-based. And they are doing a tremendous job of using that data. UPS has told me if they can save 1 mile a day from each truck over the 60,000 vehicles that they use, that they run in the United States, they can save millions of dollars if they could save 1 mile a day. Variety. Different types of file formats. Structured, unstructured data. Shape files, design files, raster files, all contribute to this variety. Here's the one I like. Variability. It goes to the example, you can see that if you can read the example, it's about going into a coffee shop. I have my favorite coffee shop every day. And I order the same thing in a coffee shop every day. But it may taste slightly different every day because maybe the water is different, maybe the temperature is different, something a little bit off that causes it to taste differently. So the other example I give is satellite imaging, which is we're going to capture the same place every day, or maybe multiple times a day. But what's different? Maybe it rained between the morning capture and the afternoon capture. The soil changes, the vegetation changes, the sunlight changes. That's variability. And then there's veracity. Think of veracity as truth. What's the truth in the data? Do I have, if you're an insurance company, or anybody who's capturing customer data, did they give you the right information, or did they put in a fake name? Maybe they put in XXX, or maybe they put in Mickey Mouse. The true veracity is really something we need to be aware of when we're capturing data. It goes to data cleansing, to be able to clean your data before you do location analytics. And then, of course, there's visualization, which we all want to do. But yes, sometimes maps are cool. I have to agree. But visualization is key. And then, of course, value is the last one, and that's the end game. You want to be able to use that location-based information that is translated into a big data problem. So, our clients at Pitney Bowes is really clamoring. We were forced to come up with a solution for big data. And so they came to us with their client needs. They wanted us to go bigger. So what we ended up doing, and this is a product that's in market, we put our geospatial processes to run natively in Hadoop. They wanted us to go faster. So some of our clients had processes that were taking literally weeks. They wanted us to do it in hours and minutes. And then they wanted us to make new discoveries with different types of spatial analytics. And that required us to put even more spatial processes natively inside of a big data framework. So right now, our solutions are certified on 2 of the big platform providers in big data cloud. They're at Hortonworks. We run most of our processes through Amazon Web Services. That is the foundation upon which we are building our software solutions. If you're not familiar with what Hadoop is, it allows us to distribute computing processes across multiple nodes. That's essentially what it is. Hadoop is an open source solution. It's Apache Hadoop is the right word. And so it really allows us to process things faster because we're splitting the data across multiple compute nodes. Our solution is called Spectrum Spatial for Big Data, and we took a part of what our spatial processes were, and then we did we only took a sliver of what we thought we could accomplish inside of Hadoop, which is geocoding, which we do for many different countries, spatial processes like spatial joins, map calculations, and then finally routing. All of these are native to Hadoop, and they run as an API within that framework. So here's the use case I want to give you very quickly before I finish up, which is on, the use case was a verified coverage map, which means tell me if I'm getting good coverage of all the cell towers I have in a particular area. So we did this for a wireless telecommunications provider in the US. And what they were doing was they were creating maps so that they could tell their engineers where to put cell towers, as well as for marketing purposes, that they could sell more wireless services to their mobile customers. So we took their call records direct from the mobile device, over 19 million call records, and we aggregated the data to 950 million cells across the United States. This took only 36 minutes. It used to take them 2 weeks to create this map. They kind of forced us to say, look, what can you do for us? And so what our process has allowed them to do is take something down from that used to take 14 days into now only 36 minutes. The background on that is we conflated, as I said, all of these location records. Some of it was SMS data, calls, data sessions. We imported ancillary data from INRIX and UCLA, which is essentially traffic management information. And then we processed the data across 56 machines and 8 CPUs. So this took a lot of work on our part to even figure out what the customer wanted, but also took a lot of re-engineering work of some of our software. So what we're able to...
You have 1 minute. You have 1 minute.
So what we did was we aggregated all these data. I said 950 million cells, and we did that in a hexagonal grid that we created. Another example is looking at where people were using a music app. Another example of reducing the time necessary to process this information. 1 billion points in only 30 minutes as well. This was 20 nodes of Elastic MapReduce, also in AWS. So the spatial data processes, this is an architectural diagram. Again, it's all within a Hadoop framework. It's taking our SDKs, putting an SDK wrapper and exposing that via an API into other location processes. So, and then we can display it out of one of our tools called Spectrum Spatial Analyst. We've also developed a process to create a spatial data lake, also in Hadoop, but it's a way to aggregate data first before you do location analytics, taking all that big data, aggregating it to a certain place, doing spatial calculations like geocoding first, and then you can do the extract to do your analytics. So sometimes the map or the satellite image is not the answer, and it is all about the data. Think of what you need to do to process the data quicker. Some of it will be done in native GIS tools. Others, you'll need different tools like a big data solution. So remember, data is the new water. We all need data, right? It is essential to our lifeline into going beyond GIS to location intelligence. So thank you very much for your time.
Thank you. Can I open up the questions to the floor, please? Questions, please. Yeah.
Hi. Thank you for the very interesting presentation. I was wondering how you handle freshness of data, especially when we talk about data lakes and making data available.
So that's going to be a real challenge, the freshness of data. So it also has to go to the point of, do we have the right data as well? So not just the freshness. So how do we keep the data? The point of the question, I think, is we're collecting an awful lot of data, right? And sometimes that data is perishable. Again, I'll use the example of satellite imagery. Once the day is over and we've got the days passed, that data is essentially perishable and we're on to the next day. Or the call records of a particular telecom provider kind of aren't useful after the day that they've happened. So I think what you're asking is, we need to do real-time data analytics, right? In order to extract the business information, there's this constant process of doing analytics and getting that right information to our decision makers. But you, as the geoscientist, may have to make a decision what's relevant and what's not. Okay.
Thank you. Thank you so much. Right. The next speaker is Moritz from Mercury Project Solution, Australia.